I'm Incident Meteorologist Jim Dudley, representing the fire team here on the Hirz incident. One of the things the incident meteorologists do is we release weather balloons, sometimes daily, sometimes when there's a need on the fire. One of the things the weather balloon can give us information on is temperature, wind, and also the relative humidity. An important thing on a fire is how the atmosphere is going to look as the balloon goes higher and higher up. One thing is also what's referred to as an inversion. When we have an inversion, as the balloon goes higher in the atmosphere, the temperature actually increases with height and it reaches a certain level. This is called the top of the inversion. The balloon continues to rise, the temperature starts to fall, and it reaches another point in the atmosphere where it starts to rise again. This would be what was called a second inversion. And this morning on this particular sounding, the balloon actually hit a layer where the temperature rises again to this point, and this is up about 12,000 feet high.
Pretty fast when you put it on 60.
And that's the top of our last inversion. So this morning we have 1, 2, 3 inversions showing on this sounding. Inversions are very, very important because air gets trapped underneath inversions, and above inversions the air wants to rise and the airflow is actually a lot better. So detection of inversions is very important. It also it dictates quite a bit what goes on other areas, and in this particular case especially smoke and where smoke is going to go. And here's a satellite image of this morning over the Hirz incident.
Hi, I'm Mike Beasley. I'm the Fire Behavior Analyst here with NorCal Team 1 on the Hirz Fire. We use the information gathered from the soundings and the balloon launches that the incident meteorologist does for some of our own modeling purposes. On this fire in particular, it's been a busy year in California, and there's been smoke from a number of other fires that have covered our fire up, and when that happens it shades our fire, and when the fuel is shaded it essentially doesn't dry out as fast during the course of the day, so that keeps fire behavior moderated. So we need to know when smoke is going to be over us, how long it's going to be over us, and when it's going to dissipate, because that dictates a lot about fire behavior. When fire behavior increases, when aircraft can fly over the fire. That visibility factor for aircraft is very important when we're dropping retardant and when we're using helicopters. And that's not all. There's other reasons that we check the inversion layer as well. There's air quality.
This is Bryce Bond. I'm the Air Resource Advisor on the Hirz Fire, and what my job is to be reporting, monitoring, and disseminating information on smoke impacts, not only to the fire, as Mike referred to, but also talking about the impacts to people as well. And so what I do is I use the information that the meteorologist produces as well as the information from the fire behavior analyst to be able to use that to come up with a prediction of smoke impacts, and also in concert with other fires that are in our area that are also influencing our air quality and the amount of smoke in the air. So what I have here is a recent model run of the fires in Northern California and Southern Oregon. So for reference, this is Redding, this is our fire, the Hirz Fire, and as you can see there's fires all over the region, both to our northeast, our northwest, and north. All of those fires are producing smoke, and so what this model is showing is the dispersion of that smoke based upon the local weather and local fuels, and over time showing us exactly where that smoke is going to be and what those impacts are going to look like.